Chapter 8 Hydroxy Compounds. Eight point one Nomenclature. At the end of this topic, students should be able to draw the structure, classify and name the hydroxy compounds which has the parent chain less or equal than carbon 10 according to the IUPAC nomenclature. Introduction. Hydroxy compound has a functional group of OH and is determined the characteristic properties of hydroxy compound. There are two types of hydroxy compound. The first is aliphatic alcohol, general formula CnH2n plus 1 OH. Second is aromatic alcohol. The example is phenol. Aliphatic alcohol, OH group attached directly to the alkyl group. Look at the structure here. The OH directly bonded to the R. The example are ethanol, cyclohexanol, phenylmethanol. There are aliphatic alcohol examples. Aromatic alcohol. OH group attached directly to the aryl group. Look at the structure there. OH directly bonded to the aryl. Phenol, 3-bromophenol, 2-methylphenol are the example of aromatic alcohol. Nomenclature. Replace the suffix of E in the alkene parent name by OL. IUPAC rules for naming alcohol have 4 steps. First, determine parent name. Second, give the lowest number to the carbon bearing the OH group. Identify the substituent groups and their position. Finally, name the alcohol. Look at the examples given. Number 1, the compound contains of 7 carbon. And we have the numbering the carbon from the right due to the presence of OH attached to it. And we must give the lowest number to the carbon bearing OH. So, number 1, 2, 3, 4, 5, 6, and 7. So, thus the name is heptanol. Look at the second example. As you can see, the parent chain of the compound determined by the longest number of carbon. So thus, numbering from carbon must come from the right due to we have to give the lowest possible number for the carbon bearing OH. So from the right, we count here number 1, 2, 3, 4, 5, 6. So thus the parent name is hexanol, and then because of now carbon number 2 attached with functional group, so thus the parent is 2-hexanol. And then we locate the number of carbon that attached with substituent. The substituent present here is methyl attached to the carbon number 2 as well as carbon number 4. Thus, the name of compound is 2,4-dimethyl 2-hexanol. Another example is 2-methyl cyclohexanol, and the below one is 2-cyclohexyl 2-propanol. If a higher priority group exists in the same molecule, which group is named as prefix hydroxy, which means OH group acts as a substituent. For example, the compound containing of 3 functional groups, carboxyl, alkyl, which is methyl, and hydroxy. So thus priority given to the functional group of carboxyl become a parent name. So thus the compound name is 5-hydroxy 2-methyl pentanoic acid. Next example, containing a four functional group, carbonyl, halogen, which is chloro, alkyl, which is methyl, and hydroxy compound, which is hydroxy. Priority given to the carbonyl act as a parent name. So thus, the name of the compound is 3-chloro, 6-hydroxy, 4-methyl heptanol. When there are two or three OH group present, the name ends with diol and triol. For example, the compound contains of the four carbons, and when numbering from right, which is give the lowest number for the first functional group present. So that's number 1 attached with OH, carbon number 3 attached with another OH. So that's the name is 1,3-butanediol. For the cyclic compound below that, the name is 1,3,5-cyclohexane triol. Classifications of alcohol. Alcohols are classified as primary, secondary, or tertiary based on the number of alkyl group or carbon atom bonded to the carbon with the OH group. Look at the structure. This is the structure for the class of primary alcohol. As you can see, there are one R, which is alkyl group, attached to the carbon with the OH. So thus, this is the structure of primary alcohol. For secondary alcohol, to show the class of secondary, there are two alkyl group which is presented as R attached to the carbon that bearing OH. So this is secondary. And finally, for the tertiary alcohol, the same way like primary and secondary, but there are three alkyl group attached to the carbon bearing OH. Thus, this is tertiary alcohol. Look at the example. Give iPad name and classify the alcohol. The name of this compound is 2,2-dimethyl-1-butanol. And how to determine the class? The class of this compound determined by the carbon that bearing OH group. This is carbon bearing OH group. And you can see that this carbon has another one carbon attached to it. So thus the class is primary. The second example, the classes of the compound is secondary alcohol. Why that is secondary alcohol? Because the carbon that bearing OH has another two carbon attached to it. So thus that is secondary. And the name of the compound is 2,4-dimethyl-3-pentanol. Compound C. The classes is tertiary alcohol. Why tertiary alcohol? Because the compound here has the carbon bearing OH, which is there are another three carbon attached to it. So thus this is tertiary alcohol. And the name is 1-methyl-cyclohexanol. And for the last example, the classes of aromatic compound here is none. And the name of the compound is phenol. Okay, that's all. Thank you.